Hello, and welcome back to the next thrilling episode of Geometry, Unit 9. For this week, we have two new topics, and we're going to move from perimeter and area stuff, which we did for the last couple of weeks, into some volume stuff. And so for the first lesson, the C.1, we'll look at volume of two particular types of solids, prisms and cylinders. And then in the next topic, we'll look at some other shapes. But before we start looking at volume, let's remind ourselves of some old stuff that we've been looking at. So with perimeter, think for a moment before I write it down. Think for a moment about what perimeter tells us and ways that we might measure it, whether it would be in like inches or square inches or cubic inches or degrees, whatever. So perimeter, as we've talked about before, tells me the distance around the edge of a shape. And since it's just a distance, that might be something that we would measure with a ruler or a yardstick, and that would be it. So maybe inches, centimeters, meters, yards, miles, kilometers, and so on. But just regular old units. Like I said, we might measure perimeter just using a regular old ruler. So, as sort of a warm-up for today, try these three problems for me, please, and find the perimeter of each of those polygons, the rectangle and the triangle, and then along the same lines, find the circumference of that circle. Pause the video and try it on your own, and when you're ready, then unpause. So here I have almost final answers. We're going to just put units on each of these, but for the rectangle, just remembering, of course, rectangles have four sides with opposite sides congruent. So I did 9 plus 18 plus another 9 plus another 18. So I got 54 as my total. And then for the units, since I just measured lengths there, I would just keep everything in meters. I can just write the letter M or the word meters, doesn't matter. For the triangle, I actually gave you more information than you needed. The 21 is part of the edge, 13 is part of the edge, and 20 is part of the edge. The triangle has three sides. Those are the three side lengths. You didn't need that 12 at all. And by coincidence, I got 54 again. And adding units to that, this time would be in feet. Not square feet, not cubic feet, just feet. And then for the circle, we don't call it perimeter, we call it circumference, but it's the same idea. It's the distance around the edge, sort of. And so we have a formula for that, which we saw last week and the week before, I suppose. So 2 pi times the radius was 2 pi times 5. And I didn't say whether I wanted an exact answer, 10 pi, or a decimal, or even how many decimal places. So however you answered is fine. But I'll add units to that. This would be in centimeters because the radius was in centimeters. So that takes care of perimeter stuff, just dealing with distance. But we've also looked at area. So area tells us something a little bit different. It tells us how much stuff can fit inside. And officially, we only talk about area with two-dimensional or flat shapes. But for area, so if I'm trying to fill up, say, this rectangle, I would have to fill it up, not with rulers, but with squares. If you're in Miss Kennedy's class, I've used my classroom as an example of this before, that if I want the area of the floor, I might count the number of square tiles that cover it. So instead of being measured in inches, we might measure area in square inches. We've seen this before in this unit as well. And you can write it as inches squared or as square inches. It might be in square centimeters or square feet or square yards, or for something really big, it might be in square miles. And so, again, to practice stuff we've seen before, take a moment and try the three problems below. Same three shapes, but this time I'm asking for their area. So pause the video and try those on your own, and then unpause to check. Be sure to include units in your answer too. This time, since we were dealing with area, the shape made a big difference. When we were dealing with the rectangle, it was base times height, and we had to make sure that we chose a base and a height that were perpendicular. Fortunately, with a rectangle, that's automatic with all these right angles. But then when we were dealing with the triangle, our formula is different. A 1/2 shows up, and we have to be extra careful that we're choosing perpendicular perpendicular lengths rather, for the base and the height. So this time the 20 wasn't helpful because I didn't have anything perpendicular to the 20. 13, I didn't have anything that made a right angle with the 13 either. So I had to use the 21 as my base so that I could use the 12 as my height, since those were the only pair that were perpendicular. And then for a circle, the formula is completely different. Pi r squared, there's that squarea thing again. And that time I just plugged in the 5 for the radius. So let's go back and do some units. Since we're measuring area, these will all be in square units. So for the rectangle, the lengths were in meters. So that means my area would be in square meters. For the triangle, the lengths were in feet. So my area would be in square feet. And for the circle, that radius was given to me just in centimeters. So its area would be in square centimeters, or centimeters squared. So that's a really quick recap of what we've looked at so far. We've also done work with arc length and sector area. We did that last week. But then this week we're going to be focusing on volume. So volume tells us something a little bit different. It's still kind of like area, tells us how much stuff can fit inside. But this time, we're talking about a 3-dimensional object. So we're talking about a box, we're talking about a cup, we're talking about something that has 3 dimensions, length and width and height, and maybe some curves and other shapes. So here, if I were trying to fill up a 3-dimensional object, for example, a box, I wouldn't fill it with rulers. I wouldn't fill it just with square tiles. I would fill it up with little cubes. And so I'm drawing some really terrible cubes in here. But you can imagine that I could try to fill up this entire shape with 3-dimensional cubes. And since it is 3-dimensional, that's why the units would be in cubic inches. So you can say inches cubed or cubic inches. Cubic feet, cubic yards, cubic centimeters, cubic miles, cubic kilometers. But there again, since we have a 3-dimensional object, it's not just flat, it has some thickness to it. A 3-dimensional object is why we measure this in something raised to the 3rd power, or cubic units. So that's our job for this week, is dealing with volume. And for this first lesson, the rest of it at least, we're going to be looking just at 2 particular types of shapes, which are closely related to each other. And we're going to look at prisms, and see some examples of those below. And then related to that, not quite the same, but the same idea, we're going to look at cylinders as well. So first off, let's define these, then we'll talk about formulas. So the 3 examples below are all examples of prisms. So a prism is a 3-dimensional shape, not flat. It's a 3-dimensional shape that does have flat sides. So they're not curved, they're not rounded at all. That's why a cylinder doesn't quite count here. It has flat sides, and it needs to have 2 congruent parallel bases. We'll talk about what we mean by base in just a minute. But it needs to have 2 bases which are congruent and parallel. So for this first example, this box over here, I could, if I wanted to, say that this rectangle at the bottom counts as 1 base, because then there is a congruent rectangle at the top that is parallel. They go the same direction and they're exactly the same size and shape. So that's a prism. Specifically, we would call that a rectangular prism because the bases are rectangles. I happen to choose the top and bottom, but for a rectangular prism, I actually have other choices as well. The front is a rectangle, and there is a matching congruent and parallel rectangle in the back, so I could say those are the bases. Likewise, I could do the left side, which is a rectangle, and then the right side, which is a congruent parallel rectangle. So for all of those reasons, that's a rectangular prism. The second one, I don't have as many choices. If I choose the left side here, which is a rectangle, I don't see a congruent parallel rectangle to that. I do see another rectangle on the other side, but it intersects the first one and they're not necessarily congruent. But this one's still a prism because this triangle on top has a congruent parallel partner underneath. So in that case, there's only one good choice for the bases. It has to be the top and bottom in that case. But it's not always the top and bottom, like in this third example. This time, the only pair of parallel congruent bases are the front and the back of this shape. Those two triangles are congruent. They're exactly the same shape and size, and they are parallel. They're going the same direction. So that's what makes these three things prisms. But the reason we're going to do cylinders at the same time is because cylinders are basically prisms. They just miss out on this flat requirement. So a cylinder, I'm going to put prism in quotation marks. But it's still the same idea that we have congruent parallel bases. We just don't have those flat sides anymore. But for a cylinder, it's kind of tuna can shape. I have a circle on top and then a congruent parallel circle on bottom. So cylinders work basically the same way as prisms, but we give them their own name, just like circumference versus perimeter, just because we don't meet that one requirement for flat sides. Cylinders have rounded edges and rounded sides. So to find volume, there's a formula for it. I will show you the formula. It's not too complicated, but more than anything, I like to think of it as a two-step process. The volume of a prism or a cylinder, volume equals a capital B, there's a reason it's capitalized, and then just a lowercase h. The capital B is to say it's not just the base like you have on a triangle or something. The capital B is to remind you that it's the area of one of the two bases. So like for this triangular prism up above, you might find the area of that triangle. For a cylinder, you might find, or you would find, the area of one of these circles. And then the height of a prism, if you always call it the height, it can get a little confusing because it doesn't always have to go up and down. So instead of calling it the height, it really means that it's the distance between the bases. So for my two examples above, for this one, the height would be vertical. For the cylinder, the height would be vertical as well, the thing that connects the two bases. But for this example right here, the height of that prism is actually sideways, or you could call this distance the height. So there's a formula. It's what, 3 letters, no big deal. But like I said, it might be helpful to think of it just as a two-step process. If I'm looking for volume of a prism or of a cylinder, or in our next lesson, pyramids and cones, I'm going to think of it in 2 steps. First, it's an area problem. And so that's going to require you to think about what the bases are and whether they are rectangles or triangles or circles or what. So we find the area of a base, and then we're going to take that answer and we're going to multiply by what's officially called the height, but I'm just going to call that the distance between the bases. There have to be two of them, so there has to be a distance between them. So the area of one of those bases, that's this capital B, and then the distance between the bases, that's what we officially call the height of the prism. So we have some examples below. The first one, you might remember from the past, just a length times width times height formula. And that's fine, but it only works for rectangular prisms, which is what we have over here. For other shapes, other types of prisms, cylinders, then that length times width times height doesn't work anymore. But our two-step process right here always works for any sort of prism or cylinder. So what I have here, let me zoom in a little bit, is I'm going to ask myself just a quick couple of questions and think of it as a process. So first, I'm going to say, is this thing a prism? And if so, what shape are its bases? Here, as we saw above, I have some different choices for what I might pick as the bases. But if I pick the bottom rectangle and the top rectangle, then they are congruent parallel bases, so this thing is a prism. And it has rectangular bases. So, like I said before, I'm going to think of it in two steps. First, I'm going to find just the area of one of those rectangles. So before I start thinking about volume, I'm going to think about area. So I'm even going to sketch that rectangle. Forgive my poor handwriting on the surface. But the rectangle I chose is 34 centimeters this way and 13 centimeters the other way. And so just like we did earlier, finding the area is going to be length times width, or lowercase b times h. But we've got 34 times 13, so I have 442 as the area of a base. And then my second job is to take that 442 and multiply it by however far I have to go to get to the other base that I highlighted. So that's why I focus so much on the bases. So since it's 25 centimeters from one base to the other, I'm going to multiply by 25. And as we've seen in this unit, you're going to get some big numbers, and that is fine. 11,050. And since we're dealing with volume, I wouldn't measure it with a ruler, so it's not centimeters. I wouldn't measure it with square tiles, so it's not square centimeters. I would have to fill up that three-dimensional shape with three-dimensional things, so cubic centimeters. For this problem, if you just did your shortcut from maybe middle school, length times width times height, it's going to get you to the same answer, and that's fine. But again, that trick only works if your bases are rectangles. If you have any other type of base, well, then we've got an issue. But this two-step process is going to take care of those issues and work the same every single time. So for the second example, I can tell this thing is a prism, not because of what the bottom is, because there's no parallel congruent rectangle, but in this case, because of the front triangle, and then a matching triangle hiding out back there. So my first step here is to say, yes, it's really a prism, because I have two congruent parallel triangles connected by flat sides. So first job, I'm going to focus just on a triangle and make an area problem. Got 20 meters across the bottom, 30 meters vertically, so that's perpendicular, that's good news. And since it's a triangle, I have 1/2 times little b times h. So forgetting about all of this stuff up here, just focusing on the triangle, I have 1/2 times this 20 on the triangle times that 30 on the triangle, and I'm ignoring the fancier picture up above. And that gives me 300 for the area of a triangle. Then I start thinking about the full shape. So I'm going to take that 300 and just multiply by the distance to the other triangle. So 300 times 29, and I have 8,700. This is in meters for my lengths, so volume would be in cubic meters to fill up that three-dimensional shape. But again, think of it in 2 steps, not as one formula. First, it's an area problem, so we go back to our old area stuff. Then we bring in the distance to the other base, and you're finished. So the next one is a cylinder. Here, again, I'm going to ask you to pause the video and try it on your own, thinking of it in 2 steps. First, find the area of a base, and then do your multiplication. So pause the video, unpause when you're ready. Okay, so this is a cylinder. It's not technically a prism, but the same idea applies because I have 2 parallel congruent circles, so I'm going to treat those like the bases. So my first job was to find the area of one of those circles. That's pi r squared, pi times 24 squared. And notice here, I didn't bother getting a decimal yet. I just did 24 squared is 576, and then I tacked on a pi at the end. I want to keep this exact for now, because if I round it just a little bit at the first step, but then I multiply by 40, then that little bit of rounding in step 1 becomes 40 times as bad in my final answer. So I'm going to keep 576 pi exact, and then I multiply by the distance between the bases. So from one circle to the other is 40 meters, and that gives me an exact answer, still with a pi symbol. Some of your calculators do that for you, but even if it doesn't, like mine doesn't, 576 times 40, and then just throw a pi on at the end. The instructions said to go to 2 decimal places, so I went ahead and did that in my calculator. On the blue and white calculators, remember your toggle button is going to do that for you. Okay. And then we have a couple of examples where we're working backwards. So let's just figure out what this is telling us, and then we'll worry about answering it. A certain prism has square bases. So 2 important things. It's a prism. It has square bases with side lengths of 6 centimeters. The prism's volume is 252 cubic centimeters. What is the height of the prism? So the fact that this is a prism tells me that I need to find the area of a base and then multiply by the distance between the bases. But again, don't think of it as a giant formula. You can think of it as a process. They told me the base, or the 2 bases, they're both squares with side lengths of 6 centimeters. So it must be 6 all the way around, because that's how squares work. So ignoring the rest of the problem, let's just think about the area of that square. The area of a square would be 6 times 6, or 6 squared, if you will, just a base times height. So I have 36 for the area of the square base. But then they didn't tell me what the height was. So I have this 36 as my base, but then I don't know the height of the prism. But I do know that the result is the volume, 252 cubic centimeters. If you were going really formula focused here, that would be fine. Volume equals area of the base times the distance between the bases. That's all I've done here. The volume is 252, and that equals the area of the base, which we found a minute ago, times the height of the prism, which is exactly what they didn't tell us. So either way, whether you think formula-wise or kind of step-by-step-wise, you're going to get the same equation. So if I want to get h by itself, well then I need to get rid of this 36. So I'm going to divide by 36 on both sides. 252 divided by 36 is exactly 7. And let's also think about units here. So some of the stuff they gave me was in centimeters, some stuff was in cubic centimeters. But think about what they're asking. The height of the prism, think for a moment about whether that makes sense to be in centimeters, or square centimeters, or cubic centimeters, or, as we saw last week, maybe even degrees. For height, we would just measure it with a ruler, or we could just measure it with a ruler. So that's just regular old centimeters. Over here, a cylindrical tank, just meaning it's a cylinder. It has a volume of 60 cubic feet, and it has a height of 8 feet. To the nearest tenth of a foot, that's just telling us how to round. It's saying what is the radius of the tank's base. Here again, pause the video and see what you can do with this on your own, and then unpause when you're ready to check or if you get stuck. Okay, so I'm not completely finished with this just yet, but just to show you where I've gotten so far. Since this is a cylinder, I know that it has 2 circular bases, and I know that the area of those circles will be pi r squared. The trouble is, I don't know what r is, so I just left it as an r. The height, or the distance between those circles, was given to me. So the area of the base is pi r squared. The height was given to me as 8. And I know that when I multiply those, I'm supposed to get the volume, which they told me was 60 cubic feet. So then I, again, just have an equation that I'm ready to solve. We saw stuff like this before, where if you have a pi involved, I think it's a good idea to deal with that kind of separate from everything else. So I'm going to not worry about the pi just yet. Right now, I'm going to worry about that 8 and get rid of that. So 60 divided by 8 gives me 7.5. Then I'll go through separately and I'll divide by pi. And I'm going to get a decimal here. We could be really picky and mean and weird about this. I'm going to go ahead and just say round it for now. It is going to throw off our final answer by just a smidge to round at this point, rather than waiting until the end, but it's not really worth the effort not to do it. But we're not totally done yet, right? Because we still have this squared, but as we've always done, that's what square roots are for. So I end up with a radius. That's the square root of 2.39. Let me find the square root button on the calculator I'm using. And so that gives me about 1.55. And then for units, since this is a radius, again, think through your options. I had stuff given in feet and cubic feet. So maybe I have feet or square feet or cubic feet or maybe even degrees. But since we're looking for a radius, I could measure that just with a ruler. So this would be measured in feet rather than square feet or anything like that. So I mentioned that the rounding might throw off our final answer by just a smidge. We rounded here, and then we still had more work to do. Don't worry about it. It'll be fine. That means if your final answer is off from the answer key just by maybe like 1 or 2 spots in the last digit, you're still fine. And that does it for prisms and cylinders. So you can go ahead and get started on the C.1 homework. And then C2, we'll just take a look at some other shapes. See you then.